Greetings. Thank you for the host arg 5. And take that off. And just don't take the mic for some reason. Alright. Hello. Good morning, or whatever it is, wherever you are. So I'm thinking we can maybe get in a couple rounds of rehearsal. Should be an exercise day later on. Right now I want to go over this again. I want to refine things. Then this afternoon I'll probably be starting to turn it into slides. I see a step. Thank you for the host as well. Then hopefully Tuesday morning I can start working from that, and maybe when my errands are done I'll have time for some more refinement there. We'll have to see. For the time being, well, it'll take me a while to get over the side. The outline over there is sort of similar, but not really. It's much more elaborate on the board. Unfortunately, I'm not sure, despite my best efforts, that it's actually readable. But that's what we got. We're also continuing to check time as we go. So is it? Let's think it's stopwatch. Unfortunately, I don't have this. I'm not going to do it right now. Is that you, Alex Wolf? Привет. And I might be able to do, offline, is figure out how to put the timer actually on the screen big enough where I can also see it. But for now, I just have to remember what I was doing here and try to run through it. Okay, so I have organized the things I want to talk about, and it's still a bit focused on those particular things. It's like comprehensive coverage of this, but I've organized it around some of the threats that we have going on, and we're trying to have safe authentication to our sites and services. We see the server database is being lost all the time. I'm not going to focus as much on some of the other issues there and more on just the authentication portion of that, where we leak passwords or information that can be used to assist in faking logins to other accounts, to those accounts and other accounts. With passwords specifically, people just choose bad passwords. And it leads to a host of problems. Even with passwords and with other methods, you always have the threat that users are going to simply lose access to their information. You have to have provisions there to allow for recovery. And that the user information could also be stolen, which means not only do they have to recover, but they want to prevent other people from doing bad things with their accounts. So that is the general area that I want to cover, and look at the solutions that we have that are going to be pointing towards what the next generation of authentication is going to look at. Now, this is heavily informed and biased and filtered by me following SQRL, which is a particular way that I saw that would attempt to kind of solve the problems with passwords, which have always just seemed really error-prone to me. So I'm not necessarily proposing comprehensive solutions. I'm not necessarily aware of all the solutions here. But these are some themes that I saw in SQRL that I've also been seeing in other places. So I think they're pointing us towards what our next generation authentication is going to look like. I'm Wendable. You can find me here. I do cool stuff in these places, and I'm going to have links to things I reference that you can look up later without having to try and scribble everything down. And I'm going to drink a lot of water. So the first threat we're looking at is a theft of the server database, which is going to leak authentication information, as well as potentially other information. The other information is going to be solved more by database encryption than by authentication technologies per se. Well, you could, if you were really hardcore, have the user provide the decryption information. But it's a little bit outside the scope of this talk right now. So you've all seen the news articles. It happens far too often, and we have ample evidence that our systems are far from perfect security-wise. We can do pretty good if you've got really good people paying attention to things. But what we know is that many if not most systems are much, much less perfect and prone to exposing things. One of the solutions, well, one of the complications with this is when your authentication is based on shared secrets, i.e. passwords and other things like them. And as the saying goes, two keep a secret if one of them is dead. So we want to have a system where we're giving the server nothing it can lose. And one of the ways we do that is with public and private key cryptography. So you give the server a public key, you keep the private key. With the private key, you can do things usually called signatures of some challenge from the server. The public key allows you to get very, very high certainty that only the holder of the private key could have made that, provided that signature. And as the name implies by public, if it gets out, it's no big deal. It could even be published on a directory somewhere. Which does sometimes happen. The method for this, and I'm running behind time a little bit right now, is one-way functions, which it is something that is easy to compute one way, in one direction, sort of the signing process, and it's hard to say impossible. There's always brute force, but cryptographers and mathematicians consider it computationally infeasible to do so in practice, to reverse the one-way function. You might be familiar with public keys from SSH. Those are typically using the RSA or DSA algorithms that are based on prime numbers, and I believe the one-way functions there have to have something to do with it's easier to do math using logarithms if you know the prime numbers involved. And then I don't know if it's I should probably look that up. If it's like you share one of the numbers and that allows you to prove the signature. In any case, one of the trends I'm seeing is a movement towards a different family of algorithms called elliptic curves, which looks sort of like this. And I know in particular with SQRL, I think it's that one there. So very, very broadly, as I understand it, not being cryptographer myself, the concept is that a key or a value in elliptic curves is a point on the curve. From that you can take a tangent, find a different point, but from that point you could have come from many, many different points, so that's your one-way function. You don't know where you came from. And then they iterate this many, many, many times to further obscure it and make it difficult to compute. One of the traits of elliptic curves is that unlike the RSA DSA the prime-based encryption, which you hear about 2048-bit keys, 4096-bit keys, as the ability to crack these gets better and better, they have to increase the key lengths. These are 256-bit keys are considered good quality amount of data, and so you see this in SQRL, you see this in cryptocurrencies. The author of SQRL said 256 bits is the new black. And in addition to having these nice compact keys, they are also reasonably efficient to compute. In the context of SQRL, there's another feature where they can use arbitrary data as a private key. We're not going to hit that in our topics today, but it is an interesting feature. And implementations are widely available. Ellipsodium is probably the most common one. It is a portable version of one that went before it called NaCl, which you might also see in context. But most operating systems and most platforms and languages will have bindings available for Ellipsodium. Another major threat that we particularly with the password-based systems is that people just choose bad passwords, which I think, well, I mean, both of these issues are kind of one of my main reasons for being interested in alternatives. So we know, and from all the password database breaches, we know what passwords people tend to use, and that leads to not always the greatest solutions, including various sorts of schemes. You may have heard, battery horse staple. But really, you want essentially long random unique passwords to be secure. So if they're hard to counterfeit, they're hard to remember, people forget them, they try to pick one and reuse it, which in combination with lost databases, reuse becomes another class of issue. Alright, so let's get this out of the way. Nope, it's this one. As we move over here, so if you're in a password-based world, one of the things that we see is use of password managers. If you're not doing this, please at least consider it. If you've got reasons to do otherwise, great. But if you're using easy to remember or reusing passwords, please look into password managers. They will allow you to generate strong passwords. They will keep track of them for you. It will allow you to either copy paste, or in many cases, especially the browser-based ones, fill out things for you. And it will try to keep that information reasonably secure on your computer. And with all of that, the password manager starts to become a sort of authentication agent for you. It's keeping track of all your information. It's often filling in forms and providing it for you. And agents is something is one of the other trends I'm starting to see. The problem is too hard for just a person, to remember the passwords and otherwise manage. So we start using agents to manage the slightly harder information that we need to do this correctly. A sort of related thing is you see application-specific apps. I think Google has one where they'll pop up the app will pop up on your phone and say, "Hey, do you really want to do this?" But this combines nicely with public keys public key cryptography, but the agent is managing your private key. I first saw this with SSH, where in PuTTY there was an agent available so that if you had your private key file set up to require a password, you might have to type that in every time you used it. The agent would decrypt it once and then keep it around so that you could easily authenticate to additional servers. And I also saw this, and if you play with the MetaMask Ethereum wallet, you may have seen that it keeps your private keys. It will, you log into it to decrypt that information on demand, and it makes the signatures on your behalf. And this is a similar method that you see with SQRL, where there is a SQRL client acting as your agent. It's keeping the keys, it's encrypting the keys, and managing and making the signatures on your behalf. Time is doing well so far. This does put a large onus on the applications to properly secure our private keys. And to keep them safe, to encrypt them well at rest, and also try and prevent, maybe take steps against various kinds of attacks that could happen against them in memory as well. Another trend I've been kind of seeing is multiple levels of encryption. So particularly in SQRL, they do very, very strong encryption of information at rest, and like even stronger encryption of information you don't need as often. And stronger meaning it's takes a while to decrypt, which means brute forcing it would multiply the attempt for each attempt to try to brute force it. But one of the caveats to the system is that you do have a large amount of user responsibility to keep their key safe, which the agents will help with a little bit, but also to make sure it's backed up and stored, or like a hard drive failure, for instance, would not lose that information. Which leads us into another thing, which is loss of user information. And one of the things I've been seeing, between SQRL and the Bitcoin things is the idea of offline storage. So if you put them with MetaMask, it told you, hey, these words are the equivalent of your private key. Put these somewhere safe, write them down, store them somewhere, stick it in a safe deposit box, whatever you need to do. Because if you lose this, if you lose your MetaMask, if you lose this, that's it. You're done. Your Ethereum's gone. Too bad. There is always out-of-band recovery. You call up customer service and you say, hey, I lost my key. Can you allow me to rekey? That opens up to social engineering attacks, but that's for public-private key systems. I need to think about where I mentioned that. And in some extreme cases, of major exchange theft, I think blockchains have agreed to roll things back. But for a simple authentication case, we already have password reset emails and the like. So one trend I'm seeing to deal with this is multi-level keys. And we never talk about that down there. So one of the things I looked up is it's a messaging system called Spider Oak Semaphore. Now, it's not authentication per se, but it includes authentication. There's some account management that we can relate to. So they also provide the sort of offline backup via a series of words that is equivalent to your private key. And then from that, we derive a more of a daily use key that you're actually, a key and identity that you're using. Now, in Semaphore's case, it's mostly its identity, and that's a key ring that actually can be replaced if need be. Yeah, that's more of a topic for later. In SQRL, we have a rescue code. Hello again. We have a rescue code, which actually is the decryption key for your actual identity unlock key, which is sort of the core identity. So you actually have to have both the, like a QR code of the data file or something, and the written down rescue code to provide the decryption information. SQRL uses that to derive what they call the identity master key, which is actually what you use on a day-to-day basis for your authentications and such. And I'm already out of water, so we're going to pause that and go get some more. And we're not quite, well, I could probably switch over and still hit that. Yeah, kind of. Move forward a little bit once you get there. Nice, let's drop down a little bit and screen a little bit. All right. So in addition to simple loss, which could do it to an extent be mitigated with simple, out-of-band customer support and such, we want to consider what happens if, particularly with the case of, I mean, it's an issue for everything, but with, private keys, okay, that's for authentication. Somebody stole it, now they can log in as me, or, steal my Bitcoin or whatever. What can we do to mitigate that? One mitigation strategy we saw with, we talked about last month, was the idea of a cold wallet. So this is a sort of, it's not part of the protocol per se, but it gives you effectively multiple levels of accounts. You've got your daily use accounts with smaller amounts of cryptocurrency. You've got your cold wallet where you squirrel stuff away, and you'll very, very rarely access it to move things out. So that's, that gives you some degree of protection. In the authentication systems that I've been looking at, you have explicitly in the system's definitions that there are multiple levels of accounts, and you assign higher levels of rights to the infrequently accessed recovery accounts. So in one of the rights at the higher level is the ability to update or restrict the lower levels, if one of them gets out and needs to be replaced or updated. In Semaphore, they maintain identity in the case of a compromise, but they have a key ring, which is a data structure that holds keys for signing, for encryption, any other thing else you might want to replace, and there is a protocol to rotate the key rings given the higher level authentication from the recovery information. And there's that water again. SQRL does not have key rings. They really only deal with signing, so you pretty much replace the identity. So that's pretty much all you would have in a key ring, so to speak. The top level key is called the identity unlock key. It is the highly encrypted offline storage thing that you bring in emergencies. And you have a daily use of the identity master key, which there is a provision to replace those if need be. When you first authenticate to a site with SQRL, you provide additional lock information. As long as that is present, the identity is considered locked. That is essentially it's the essentially the public key, to simplify things a little bit, to your identity unlock key that says, okay, here is how you verify a request to replace identities. When a request is made, there's a provision for both your current identity and signature and your previous identity and signature. And then, if the unlocked signature is available, the site is permitted to replace the previous with the current. There's additionally a provision to disable accounts using only your basic level of rights. You could potentially have a denial of service attack if somebody got your private key, but really what you want to do is go around and disable all your accounts anyway so they can't use them. So you can do that with your regular account level, assuming they didn't actually, take your device or whatever. As long as you've got a device that has your daily use your identity master key, you can go around, disable all your important accounts, and then, go get your safety deposit box to get your unlock key and actually replace identities, re-enable the accounts, and continue doing that stuff. So those are the big themes I wanted to talk about. We protect from theft of server databases by using public keys, which, since they're public, the server has nothing to lose. Other personal benefit or identifiable information things that could be a whole different topic about encryption and such. We have, weak passwords and bad passwords, which are partially addressed by agents. The user can still have a weak password to their agent. The agent's database of passwords or private keys essentially becomes sort of a something you have, and with password is something so it's a little bit better. That's the point I should be making. We protect from loss of user information by taking that agent information and it's education and just strong encouragement is all you can do. To store this stuff offline, have the super secret safe place to put stuff. And we protect against theft of user information by having multiple levels of user rights, so that the stuff that you're using day to day and that is more exposed is not the ultimate authority. You have higher levels of authority you can back up to in the case of a compromise to regain control of your accounts and replace the lost information with new information. Alright, so we're at 24 minutes. No one responded with interest in particular other topics, so we're just gonna leave some room for Q&A. That'll be a pretty good time profile. So what were the things I was thinking about? Oh, in agents, we have these concepts in security. I think it says with authentication specifically. I might also want to touch on authentication versus authorization. Most people probably know that. Hopefully it'll be useful from the context. Alright, so the point I want to make is that there are these three concepts in authentication. There is something passwords, usually, passphrases, code words. Something you have, which I think in this context files count. Files can often be easily exfiltrated, but it's the key to a lock, for instance. And something you are, what starts to get into biometrics, which we've seen, and they can be faked. How do we present that? That's kind of agents, password managers storing databases. So we have something you know. Which was your password. Let's figure out where this fits in, and that's altogether off, isn't it? Yeah. Also, my head's in the way. And then you have something you know. No, something you have. And we can touch on something you are, although it can be a factor. An agent could be, maybe your agent, such as your phone, could be using a fingerprint. It's up to the security of the system to say that that's a real fingerprint, not a fake fingerprint. So where does that fit into the discussion? We talk about password managers, keeping databases, agents. Probably this follows on from agents. Now this could start to become a help point that moves everything down by 1 minute. Maybe I could actually insert that before agents. Because we go, password is something you know. Once we have the idea of generating and storing passwords, we have the idea of the password database being something you have. And then when we get into filling in information, that starts to become more of an agent relationship. So I don't know if that will actually bump it down by a minute, but it's going to be enough stuff that it might. Yeah, I usually end up going a little bit faster anyway. Yeah, unfortunately the paint is not great for sticky notes. So we'll probably have at least one more run through this morning. So you can spot any other areas that need improvement. We'll talk about the principles of security, and having the password manager starts to become that, and agents in general fill that role. Yeah, we'll have time for about one more run through. Alright, however, I was drinking a lot of water, so I'm going to take a short break. I'll be back in a minute or two. Okay. So I need this back over here. Reset. Alright, rehearsal take 2. We'll see how that new stuff fits in. And time is good enough right now that I should probably stop and put in any little fixes I see, just to make sure I get them down. It's repeatable enough. Alright, so I've got a couple of things, themes I want to talk about, and I've organized them under some of the common threats we have to authentication systems. First, we've got, theft of server databases, which I'm sure you're all familiar with. And one thing I'm actually not sure about is, should I be mentioning the solutions we're going to talk about up front, because it's kind of the outline, and like the outline of the topic is this, or is it like we're keeping a little bit of suspense for what the solution to that is going to be? We could definitely do that in the wrap-up outline. Anyway, secondly, that in passwords in particular, we have just bad passwords running rampant, and that compounds with theft of the server databases. Information can also be lost on the user side, which requires processes to restore them, which are then themselves subject to social engineering attacks and such. And we can also have, well, no, loss of user information is, they call up server support. Theft of user information, it could also be, I guess, the social engineering attacks, which means that not only do you have the user to get their access back, but you need to cut off the thief. So I want to talk about next generation authentication solutions. It's going to revolve a lot around something called SQRL, which is the sort of what got me into this. It's like, hey, that's an alternative to passwords. Passwords kind of stink. So I'm not necessarily going to be doing comprehensive solutions to these problems. My understanding, the things I know about and the things I understand are a bit filtered by my interest in this one topic and some other things I've seen. So take that as a caveat, and if you know more about some of this stuff, maybe you should do a presentation. Anyway. Hi, I am Wendable. I do cool stuff, and you can find me here, and I'm going to have links to the references in this talk if you want to look things up more, or ask me questions, but that's all the other references. So our first threat is theft of the server database, which I hardly need to recount all of the instances where this happened. This is just the selection of the ones from when I did this a few years ago, and there's been plenty more since. There's almost new ones daily. So one of the issues with, well, there's a lot of issues with theft of server database. I'm not going to be addressing as much like encryption of the server database, which is going to be an issue with other information, names and email addresses and phone numbers and heaven help you, social security numbers. I'm going to focus on the authentication information because that's just my area of interest right now. And one of the problems we have there is shared secrets. With, as the expression goes, two can keep a secret if one of them is dead. So if you and the server share a secret, there are two places where that information can get out. So what we want to do is create a situation where there is simply nothing for the server to lose. We like that for this user as well, but the server databases are the big, it's where lots and lots of user information is. If you're subject to a targeted attack, that stinks. But server databases, tend to have lots of authentication information and other good stuff. So we want to give them, we want to reduce the value of those as much as possible. The way we give them nothing to lose is by giving them, instead of passwords, public keys where the user keeps the matching private key. This is public-private key cryptography, if you're not familiar with the terms. The idea is that the user holding the private key can create things called signatures. With the public key, you can say with a high degree of confidence that only the holder of the private key could have made that signature and no one else. So, given a little bit of care in that you are always doing unique challenges and such, this gives us a great degree of confidence that it is the real user logging in. This is accomplished via one-way functions, which mathematicians and cryptographers agree by our current level of understanding. You can take this function in one direction, and it is, computationally infeasible to take it the other way. You may be familiar with this in SSH. SSH uses a family of RSA and DSA based on one-way functions of prime numbers, multiplication of prime numbers. So I think that's something to do with you can do things much easier with logarithms, given that you know these numbers. The family of one-way functions that I've been seeing crop up lately is elliptic curves. Some elliptic curves look sort of like this. This is a family of functions here, and I think the one SQRL uses is that one right there. So very, very broadly, I think, as my sort of lay understanding, the idea is that a key in elliptic curves is a point on the curve. So you take for instance, the tangent to that as it curves around a lot, you will hit another point on the curve. However, you could have arrived at that point on that new point from any number of other points on the curve. So that is your one-way function. You don't know where you came from, and then they will iterate this many, many times to essentially make it infeasible to calculate the path you took to get there. Now, one of the reasons that ecliptic curves are interesting right now is that they have very, very compact keys. So whereas the prime-based encryption, common here like 2048, 4096 bit keys. Elliptic curves are considered very, very good at 256 bits, which you might remember from your cryptocurrencies. It's in SQRL, it's in a lot of other places. One of my references is a very long list of places that are using just the particular elliptic curve that SQRL uses. And the author of SQRL once said the 256 bits is the new black, which it's kind of that thing. They're also efficient to compute, which is something that you want as long as it's still hard to computationally infeasible to attack. There's a few additional benefits. For SQRL is the ability to use arbitrary private keys. I'm not going to get to that today, but it's a neat little feature. And the implementations are widely available. Usually you'll see Libsodium, which has implementations for pretty much all platforms and bindings in most languages. And you might also see NaCl. Libsodium is basically a more portable implementation of NaCl. So, second major factor I want to consider is, with passwords in particular, people just use passwords. And we know this because of all the password leaks we've got. We know the frequency, we know the passwords they're using. So this is getting a little bit better known. So you start seeing password schemes like battery horse staple, if you've seen that XKCD. Trying to choose patterns that are still somehow memorable but secure. And of course, if it's memorable, it's also easier to crack. You really want random passwords. Random passwords are hard to remember. They get forgotten. People try to use, they'll say, oh, well, I'll have one really good password and use it everywhere. And, well, if it gets out once, then these hackers can use it everywhere. So one of the solutions to this is to use a password manager. And if you're not using one, please consider it and make sure what you are doing is at least as good. So part of the idea here is that password managers will help you generate good passwords and then keep that list of unique passwords for every site for you in an encrypted database, which essentially turns the encrypted database, which you still have to have a password to decrypt it usually, though it could be other means. So what that becomes, that database becomes something you have. And in authentication, there is the concept of, something you know, something you have, something you are. Something you are, so to get into biometrics, your phone, for instance, might have a password, a fingerprint, which, you could be used to encrypt your password database, for instance. But typically, like a password manager, you have your password to your password manager. So that's the one password you have to remember now. And then the database itself is something you have. So that's two things that have to be attacked before they can get your stuff. Password managers will also often, in addition to letting you copy-paste these things, especially with the browser plugins, will actually be able to do form fills for you. At which point, it starts to become your authentication agent, which is the other theme that I'm kind of seeing. So we see other types of agents. Google has this thing, this app, where you attempt to log in and you get the pop-up on your phone that says, hey, we saw this login attempt, do you want to do this or not? There are various application-specific versions of that. But then this starts to become interesting when you have public and private keys and users have to keep track of their private keys. So now the agents are the things holding the private keys and making signatures on the user's behalf. I first encountered this with SSH. The PuTTY client had an agent available. And if you have a public-private SSH pair, very often you will encrypt your private key, which will then require you to provide the password every time you decrypt it. An agent will allow you to decrypt it once and hold it in memory to be used on demand. And then you may have also, we recently talked about cryptocurrency wallets, which are essentially holding your private key and making transactions and signatures on your behalf. SQRL is also based on the concept of being an agent, holding your private keys, making authentications and performing the protocol on your behalf. So we're seeing lots of things that are based on some sort of agent or device, or be it software or hardware. And it's very, very important for these things to secure that private key, which will usually mean encrypting it. And sometimes this will go to hardware where the hardware is performing maybe encryption, but signing and things on your behalf on the hardware device to minimize the risk of leaking the private information. Even when you are in software, something I've been seeing is multiple levels of encryption. SQRL could be said to have at least 3 levels. You've got your recovery information that's like, you could wait a minute, 5 minutes to decrypt this. That will just make it harder to attack, but since you never need to do it, it's not a big burden. Then your daily use information takes maybe a couple of seconds to decrypt. And once you've decrypted that with your hopefully very strong password, you can get to a more session usable level where you only have to put in, say, the first 4 characters of your big password. And that will, quickly decrypt things, do a quick decryption, use it, and then throw away the decrypted version again. But if you botch that 4-character password, then it just throws out that lightning encrypted one and requires you to re-enter the full one. You also see this, you might see this, for instance, in your phone, where you can, I know at least Apple does this, where you put in your Apple password when you first start up, or once a day, or every couple of days, and then, but you can do your fingerprint for, day-to-day type stuff. Now, with something you have, be it, and this sort of goes for all private keys or agents in general, is, it puts some onus on the user to maintain their private key or the password vault. With private keys in particular, if you're sort of using it to its fullest potential, where only the user has the private key, if they lose that, they lose it. If it's cryptocurrency, you've lost your coins. There's not a whole lot you can do about it. Which leads us into one of our other themes, which is loss of user information and how you recover from that. And one of the things I see as a possible solution to that is offline storage. Or, you have backups in general, but very often these systems encourage you to sort of write this down, put it in a safe deposit box, something of that sort. If you used MetaMask from Ethereum last time, you may have seen, here's these words, write them down, store them someplace safe. And these words are, I think in that case they are essentially your private key. Something I see with SQRL and other systems is the concept of multiple levels of keys. And once again, I'm hitting a point where I run out of water. Fortunately, I have a larger water bottle when I'm doing talks. And we might be able to switch here. Get the timer over there where I can see it. I think I have to get kind of close here. Alright, I'm still not in the way of the bottom stuff here. Alright, so we were at about 17 minutes talking about MetaMask words, multi-level keys. So a trend that I'm seeing in some of these other systems is that you actually have multiple levels of keys. So one of the systems that I sort of looked up, just looking for additional examples, is Spider Oak Semaphore. Now they also give you a recovery code in the form of a set of words, but they then from that derive more daily use information, so that you don't actually need to have that recovery information around where someone could get to it. Actually, we're not talking about that yet. And then there is a more daily use key. And Z1 Gaming, thank you for the host. Welcome if you're there. I don't think I know you currently, but welcome. And pardon if I've forgotten a name. I'm really, really terrible with names. Anyway, we then from the recovery code we derive more of a daily use identity. This is also something we see in SQRL. There is your ultimate identity unlock key that you hopefully only use in emergencies. And I think that in their case, it is actually storing that heavily encrypted and giving you a recovery code to decrypt it. I don't know if that's like an information compression thing or what. Interesting. But that does mean that you have to sort of like, look at QR code, for instance, of like the encrypted vault, and then also write down the recovery code. And then for day-to-day use, there's an identity master key, which is actually used for logging into sites and such. Now, now we have loss of user information, but we also, the user needs to recover their identity. We also have concerns about theft of user information, where not only do we have to recover our own access to the account, we want to cut out other people from accessing the account. So we have to consider theft of user information. Now, in last month, we talked about, there was discussion about cold wallets, the idea that you keep the bulk of your cryptocurrency in an account where you can, because you can send to public key addresses. You can sort of store stuff away there. And then very rarely you will actually, warm up your wallet to send stuff out, try to keep that as minimal and safe as possible. All right, cold wallets. The time is doing good. Now, that is a sort of out of protocol strategy people have developed within the cryptocurrency systems. Some of the other systems I've looked at, you actually have explicit protocol around having multiple levels of accounts and the rights available to those accounts. With cold wallets, it's just kind of how you use it. The other systems have very, very explicit in the protocol how we manage this. So with SpiderOak's semaphores, well, yeah, we have levels and rights. The rotation of keys is starting to make me think about creation of keys, rotation of identities. And so typically you will have a sort of recovery identity which has the right to update the lower level identities, and there are certain things that you specialize to that. So in Semaphore, for instance, they have the concept of a key ring. They will actually, if identity is compromised, you maintain the identity, but you rotate the key ring, which actually contains the signing key, the encryption key, and anything else that would actually be of value. SQRL, since it only has the signing keys, it says, okay, the key is the identity, and they call it replacing an identity because the identity basically is the signing key. In that context, the identity unlock key is your top level key with the permission to replace what they call identity master keys. It's more of your daily use thing. When you authenticate and sort of sign up at a site with SQRL, you also provide additional lock information, which, to oversimplify a little bit, is a public key for your recovery key, so to speak, for your identity unlock key. And then there's a provision in the protocol to provide not only a current identity, but a previous identity. And if you're only known by the previous identity, then you can provide a sort of, bring your unlock key, out of cold storage, so to speak, to provide that additional signature to say, okay, it's okay to replace that. Additionally, SQRL has a provision to where your identity master, your daily use key, can disable the account. Theoretically, somebody could sort of do a denial of service, but really, if they've got your account, you want to go disable it before they can use it anyway. And that allows you to, quickly hit up your important accounts if you think you've lost control of your your identity master key, and then go to your safe deposit box to get your rescue code in order to go replace your identities and re-enable things. So those are the topics I wanted to cover. I'd be interested to hear what you think of that and what other things you might want to talk about. The solutions, the problems and solutions we've discussed so far are loss of the server database, which we answer by giving people, at least for authentication purposes, answer by only giving people public keys instead of shared secrets. We have just passwords in general, and sort of users choosing bad passwords. We answer by using agents, especially in combination with managing the private keys to go along with that public key, and turning that into a sort of something you have in addition to something you know. We try to address the greater user responsibility by possible loss of those public keys and that thing you have by using offline storage and multiple levels of keys, and especially in the case of theft of user information, we actually want to give those keys multiple levels of rights, so that if you lose the information you're keeping around on a daily basis, you have a way to replace that information, update that information, lock out the attackers without having to go through customer support, and which will be subject to social engineering attacks. And those are, and that is what I want to talk about, and we've got plenty of time for questions. All right, so that is running, actually running about 20, well, I don't have any post-its for the outline wrap-up stuff, really. That's actually kind of up here now. And we just got a lot of time for Q&A. All right, so that has been running through without too much patch-up and interruptions. I'll probably come up with more stuff as I start getting into slides. So I think probably I'm going to start rearranging my previous slide decks and filling in things this afternoon. So that'll be a little bit different. I'll have to see how this actually works out. Probably if I'm making that my primary screen, this view won't even be really useful. I don't even know if it's useful at full screen. So we'll be back with that, and what I need to do right now is get a little exercise. So that's something I can shut down. It's blinking at me. All right, so I need to rearrange a whole bunch of stuff. I will try to get something back up relatively quickly. But I am going to need to change scenes, change profiles, and then I can get at least up a starting screen message. That will be on Twitch only. I'm too nervous about YouTube's copyright policy to do step media on there. Or it'll take a lot of preparation to make that safe anyway. So yeah, I'll be back as Step Mania in a little bit. It could take me a couple minutes to switch over, and then a couple more minutes to get the pad set up. And if you're here for authentication, from that interesting, but that's what I'm doing. So thanks for watching. Thanks to SDS Dev, Stormy, Clifford, McGrime, and it's moving around on me. Arg5, Z1 Gaming, YT, Catnox for hosting me. I'll be hosting people later, but not right now. Thanks for hanging out. I should have put this up sooner in case anybody stopped in. Thanks for stopping in. I'm going to get back to Step Mania. Bye. See you in a few minutes.